Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring function notation. When expressing function rules, we often use something called function notation instead of y equals to describe functions. So for an example, we have a function over here, f of x is equal to 2x minus 5. The f of x is another way of writing y equals. Think of it as a fancy way of writing y equals. Now, we don't always use the letter f. Sometimes you might have g of x or h of x, but all of that is function notation. Now, the parts of function notation, the f represents the name of the function. So in this case, this function is function f. The variable that's in parentheses, this is your input variable. It tells you what to put in, what number to put into the function. And the expression on the right side is your function rule. It tells you what to do with your input variable. So in this function rule, you take your input variable, multiply it by 2, and then subtract 5. All right. So let's look at example 1, and let's just practice a little bit with some function rules and talk about how to read them. So in example 1, it says use the function rules to fill in the chart below. So our first function rule is f of x is equal to x divided by 2. So our name of our function, you look at the parentheses, and the variable to the left of the parentheses is f. So this function rule, the name of the function would be f. The input variable is the variable inside the parentheses. So x is our input variable. Now, how is the output variable obtained? Well, you divide the input by 2. You divide the input by 2. All right, so our next function rule, we have g of x is equal to x squared minus 3. So the name of this function would be g. Our input variable, again, is x. And how is the output value obtained? Well, we need to follow our order of operations. So in our order of operations, squaring would come before subtraction. So we're going to square the input and then subtract 3. All right. Our next function, h of t, is equal to negative 16 times t squared. So the name of our function is h. This time our input variable is t. All right. Now, how is the output value obtained? Now remember to follow your order of operations. We want to square first and then multiply. So you would square the input and then multiply by negative 16. All right, let's look at an example 2. A function is defined using the formula f of x is equal to x divided by 4 plus 3. Evaluate the function for f of 8 and f of negative 12. So in this problem, here are your input values. They're giving you 2 different input values. All right, so let's write the function rule that we're going to use down again. F of x is equal to x divided by 4 plus 3. So here's how we're going to get our output. You're going to take your input, you're going to divide it by 4, and then you're going to add 3. Take your input, divide it by 4, and add 3. So if I wanted to find f of 8, they're telling you that your input value is 8. So I'm going to take 8 and divide it by 4 and then I'm going to add 3. So f of 8 would equal to 2 plus 3. So f of 8 is equal to 5. So we evaluated the function for f of 8. Now let's evaluate the same function rule if your input is negative 12. If your input is negative 12, that means you'll put negative 12, you'll divide it by 4, and then you'll add 3. So f of negative 12 equals negative 3 plus 3. So f of negative 12 is equal to 0. All right, B. What two coordinate points would lie on the graph of this function based on your answers to part A? Based on your answers to part A. So let's look at our first function. We have f of 8 is equal to 5. So when your input is 8, in other words, when your x value is 8, your output value is 5. So my first point that would be on the graph of the function is 8, 5. My second point, if your x value is negative 12, you get an output of 0. So those 2 points would lie on the graph of the function f of x equals x divided by 4 plus 3. All right, example 3. The graph below shows a function f of x. Use the graph to answer the questions. All right. Question A. Express point A in function notation. So here's point A here. Let's write the coordinates of that point. So that's negative 1, negative 2. So let me write it above it. All right. So if I wanted to write that in function notation, I would put f of, your input always goes in the parentheses. So our x value is negative 1. And then your output value would go on the right side. So f of negative 1 would equal negative 2. All right, try question B on your own. Pause the video and then press play again once you think you have an answer. All right, welcome back. The first thing I did for this one is I wrote down the coordinates of point B to be 2, 1, and then I put my x value in the parenthesis and my y value on the right side. All right, problem C. Evaluate f of 0. So this is saying when x is 0, what is the value of y? All right, so here's x equals 0, and I want the y value on this function. So I would travel down to right here, and let me label that point. When x is 0, the y value is negative 1. So this f of 0 would equal negative 1. All right, evaluate f of negative 3. So if I go to the left 3, I want to know how many would I go up or down. So go left 3, 1, 2, 3, and then I would have to travel down 1, 2, 3. So this is the point, negative 3, negative 3. So f of negative 3 is equal to negative 3. All right, now in example 4, they're not going to give you in a graph, but they're still going to ask you to evaluate different functions for a given value. So in example 4, it says use the function rules below to evaluate each function. So we have f of x equals 5 times the quantity 2 minus x. G of x is equal to x squared minus 3. And h of x is equal to x minus 3 divided by 2. So in problem A, they want us to evaluate h of 13. So highlight which function you're using. So if you're evaluating function h, then what I want you to do is write down the function rule for function h. So our function rule is h of x equals x minus 3 divided by 2. All right, now they want you to evaluate this function for when x is equal to 13. So they're asking you to find h of 13. So that's your input value. So if I put 13 into my function, it wants to know what would I get out. So h of 13 equals 13 minus 3 is 10 divided by 2. So h of 13 is equal to 5. Okay. Problem B. In problem B, they're asking us to evaluate f of negative 5. So it's important that you first write down the function rule for function f. And the excuse me, the function rule for function f is f of x equals 5 times the quantity 2 minus x. All right. So if I'm evaluating f of negative 5, they're telling me they want me to put a negative 5 into this function. That's my input. So 5 times the quantity, 2 minus negative 5. So f of negative 5 equals 5 times the quantity. Remember, we have minus, minus. So that becomes plus, plus. So this would be 5 times 7. So f of negative 5 equals 35. All right, g of negative 4. So let's highlight which function they want us to work with. They want us to work with the g of x formula. So let's write down that function rule. G of x is equal to x squared minus 3. They want us to find g of negative 4. So that means I'm going to take negative 4 and square it minus 3. Oh, and on this problem, the parentheses are very important because we want to make sure we're squaring the negative 4. So g of negative 4 equals, all right, so negative 4 squared is the same thing as negative 4 times negative 4, which would be positive 16 minus 3. So g of negative 4 is equal to 13. All right, pause the video and try problem D on your own. All right, welcome back. Let's see how you did. The first thing I wrote down is the function rule for function f, which is 5 times the quantity 2 minus x. So f of 0 is equal to 5 times the quantity 2 minus 0. So f of 0 equals 5 times the quantity 2. So f of 0 is equal to 10. If necessary, pause the video to correct anything that you might have gotten wrong. All right. In example 5, two functions are shown below. Use the graph to answer the questions. So on this one, you must be very careful to look at which function they're asking you to evaluate. So f of x is going to represent the line, and g of x will represent this upside down U shape. All right, f will represent the line, and g is going to represent the U shape. All right, so the number inside your parenthesis, your x, tells you how many to go left or right. Okay, so, well, let me erase that because it's negative. That means I'm going to, if I go left 3, I'll write this down. If I go to the left 3, they want to know how many would I have to go up or down to reach that function. So let's count that on our graph. Starting at 0, 0, go left 3, 1, 2, 3. And to get to the line, I would have to move up 1, 2, 3. So f of negative 3 is equal to 3. All right, g of negative 2. So this is saying I'm going left 2 And they want to know how many would you have to go up or down to get to the g function. How many would you have to go up or down to get to the g function? So starting at 0, 0, I want you to go to the left 2 units. So 1, 2. Now, how many would I have to move up to hit that U shape? And notice I would only have to move up 1 unit. So g of negative 2 is equal to positive 1. All right. Problem C, they want us to evaluate g of negative 3. So again, I'm moving to the left 3 units. So if I move to the left 3 units, how many units would I have to go up or down to reach function g? So 1, 2, 3. To get to function d, I would have to move down 1 unit. So that would be negative 1. All right, pause the video and try problem D on your own. All right, welcome back. Let's see how you did. In problem D, we're moving to the right 3 units, and I want to know how many would I have to move up or down. So 1, 2, 3, and I would not have to move up or down any units. 0. So I didn't move up or down. Okay. Now, we've talked about how to evaluate functions if we're given equations, how to evaluate functions if we're given a graph, and how to evaluate functions given a table. I saved the easiest part for last, all right? So in this table, it says the table below shows some values for the functions f and g. Use the table to answer the questions. Find each of the following. So if I want to evaluate f of 3, that tells me my x value is 3. So let me highlight that. If your input is 3, they want to know what would the output be in function f. So it's very important that you only look at the column that says f of x. So that would be 4. Okay. All right, in the next problem, they want you to evaluate g of 4. So your x value is 4, and they want to know what would the value of g of x be. So go over to g of x, and that would be 3. All right, pause the video and try problem C and D on your own. All right, let's look and see. Welcome back. Let's see how you did. For g of 1, that would be negative 3. And f of 2, that would be also negative 3. And that concludes today's lesson, evaluating functions written in function notation.